Hi, my name is Yusuf Zidan. I'm 40-MET student. I'm going to talk today about the embedded project, about the code. First, we have I will talk about the pin assignments. First, we have the motor pins, which are three. The enable pin, which is set only once at the beginning. And then we have two pins. Depending on whether they are high, low, the motor will stop. If they are 0, 1, the motor will go forward. If they are 1, 0, the motor will go backward. And then we have the ultrasonic pins. We have two sensors, two ultrasonic sensors. So we have each of them have two pins. The two pins are the trigger pin and the echo pin. And about the joystick pins, we have also two analog pins, which are on the X direction and the Y direction, which control the movements. And then we will talk about the start bottoms temperature and light pins. We have a button for we have a temperature sensor pin and LDR pin. The two are analogs and control the input. And we have three other pins, which are the output pins, the LED pins, which are also assigned.
Hi, my name is Gasser. I'll be talking today about my contribution in the embedded project. I will be talking about the scheduling of the tasks that are in our project, as well as the semaphores used. First of all, we have 6 tasks in total. I'll be talking about the first 3. The first 3 are RFID task and the button task, as well as the ultrasonic task. I just mentioned them in their own priority. The RFID having the highest priority and the ultrasonic having the lowest priority in what I talked about till now. First of all, the RFID task tries to take a special semaphore. This semaphore is only taken once at the beginning of its execution, and then the task keeps looping, waiting to read a card. Once the card is read, the LCD screen will print a car unlocked message, and then it will give the unlock semaphore. This semaphore will then wake up the button task. The button task, which has the priority of 7. The button task will keep on running, waiting for the button to be put on the high state. Once it's on the high state, a message on the LCD screen will be printed, and the semaphore go will be given. This semaphore will then wake up all other tasks. All other tasks like the ultrasonic sensor, the light task, the temperature task, as well as the time task at the end. Once this semaphore is given, the first task that will run is the ultrasonic sensor. The ultrasonic sensor has the first highest priority between the other tasks, other than the RFID and the button task. The ultrasonic task will keep on running. It will read first the 2 distances from both sensors, and if the distance is more than 10 centimeters, the motor will be allowed to move. But the motor will only move when we put a direction on the joystick. If we put a direction forward, the motor will move forward by giving a high-low signal, and the gear will be put on D. Otherwise, if it's on the back side, the gear will be put on R, which is displayed on the LCD screen, and the signal will be flipped from low to high. If at any point the distance is less than 10, the buzzer will sound, either in the front or the back direction, so the car will be stopped. Each time the ultrasonic task runs, it will take the go semaphore, and once it finishes its execution, it will release the go semaphore, which will then allow another task to run. However, if at any point we put down the button to the low state, the is responsible for running the other task, which is the RFID task. Once the RFID task has the semaphore, it will try to keep waiting to lock the card. If at any point the card is detected on the RFID reader, the semaphore unlock will be taken and the car will be locked.
I'm going to talk about the ultrasonic sensor task. It begins when it takes the semaphore, and when it ends its task, it gives the semaphore again for the light task, which has a lower priority, to start. The light task works if the LDR with the LDR. If it's lower, it works. If it's higher, then it doesn't work. Then the light task gives the semaphore again to the temperature and time task. The temperature task is not periodic, not like the ultrasonic and light tasks, and it has a delay of 10 seconds, so it works every 10 seconds. And when it is not working, it gives the semaphore again to the time task. The time task is also continuous, but it doesn't have any kind of a delay because it is always working and it takes its input from the RTC.
Hi, I'm Ahmed Hisham. I'm going to be talking about my contribution in this embedded project. I will be talking about the ultrasonic and the automatic braking system. In the ultrasonic, it's connected to 5-volt VCC and the ground, and it has the trig and the echo. The ultrasonic is like a receiver-transmitter way. At first, the echo is the echo is high. The trig is high for 10 microseconds, and then it becomes low. Data is transmitted to detect the distance between the ultrasonic and the object through the echo and the trig. The echo sends the sound waves, and it's reflected. Once it's reflected, it comes back to the trig to detect it. This calculates the time it travels, and we already know the ultrasonic, the sound wave speed. So we calculate the distance, and we use this distance for the braking, for stopping the motors, and also for the buzzer to start. For the H bridge and the motors, the H bridge controls the movement of the motors. At first, it's low, so there is no movement. When we direct the joystick, it moves forward, so it becomes high-low. And when we move it backwards, we change the direction of the joystick, so it becomes low-high. This changes the direction of the motor forward or backwards. And the H bridge controls the motors. Also, the H bridge supply the motors with the 11 volts from the battery, as the Arduino supply is not enough to make the motor runs for 4 motors. It's not sufficient, so we use also the 11 volts from the battery.
Hello, my name is Hisham. I'll be talking about my contribution in the embedded system project. I'll be talking first about the potentiometer. The potentiometer only has 3 pins to connect: a ground and a voltage, and the middle pin goes to the LCD. The LCD first is connected ground, then the voltage, which is 5 volts. Then we have the pin connected to the potentiometer to adjust the contrast. Then here is the register select pin, which is connected to the transmitter pin 18 in the Arduino board. Then we have the write and read pin, which is connected to the ground. Then we have the enable pin, which is connected to pin 2 in the Arduino. Then we have the data pins from D4 to D7, which are connected to in the Arduino from pin 4 to 7 respectively. Lastly, we have the ground, the cathode, and the anode. I will be talking about the joystick. The joystick contains of the first pin is the ground, the second is for the voltage, then for the X direction and the Y direction. They are connected in the pins of they are connected to the analog pins A0 and A1, and the last pin is not connected because it's functionality for the button and we don't use it. Then we're talking about the temperature sensor. It's here. First, it needs 3 pins to be connected: a ground and a voltage, and a pin to the Arduino, which is connected to the also an analog pin, which is A2.
Hi, my name is Ahmed Mohammed Salah, 40-MAT. I'll be talking about my contribution in the project. Basically, I was responsible for connecting the RFID along with the LDR and the RTC. So the RFID was the only component we used that was connected to the 3.3 volts from the Arduino board, and it has two pins connected to the PWM pins in the Arduino board as well. And this is a small demonstration about it. We use it to unlock and lock the car. And next I'll be talking about the LDR. It has two legs. One leg is connected to the 5 volts voltage, and the other pin is connected to a resistor, which is also connected to an analog pin straight to the Arduino board. And the other leg of the resistor is connected to the negative ground on the board. We added the resistor to adjust the readings on the LDR to get accurate values of the room light. And about the RTC has 4 pins. The negative pin connected to the ground of the board, and the positive 5 volts connected to the positive 5 volts on the board. And we have 2 pins. They're responsible for the I2C communication, one connected to the SDA and one connected to the SCL. Every time we connect the RTC, we have to run the file downloaded with the library of the RTC to set the date and time of the RTC, and then it automatically counts the seconds and the time according to the real-time clock.